Raise your right hand. Now look at your reflection. It raised its hand too, but the wrong one. You lifted your right. The figure in the glass lifted its left. You wink your right eye. It winks its left. And somewhere, very early, somebody told you the explanation. Mirrors reverse left and right. Everybody knows that. So here is the question that should keep you up tonight. If a mirror reverses left and right, why doesn't it reverse up and down? Your head is up in the glass. Your feet are down. Vertical is fine. Only horizontal got swapped. How does a flat sheet of glass know the difference? How does it flip one axis and leave the other one perfectly alone? Stay with me for the next half hour, because the answer is not the one the famous version gives you. The most popular explanation on the internet tells you it's all in your head, that the mirror does nothing, that you fool yourself. That's half true, and the half it leaves out is the most important fact about the shape of the universe that anyone has ever measured. Here's the thing. The mirror does not reverse left and right. It never did. But it does not reverse nothing, either. It reverses exactly one direction, and it's a direction you've never once said out loud while standing at a sink. Not left, not right, not up, not down. The mirror flips the one axis that runs straight through the glass, front to back, depth. And that single flip, the one nobody mentions, turns out to be the same operation that, in 1957, broke a law physicists had trusted for 300 years. The bathroom mirror in front of you every morning is performing, in miniature, the one move the universe cannot copy. Most channels treat that as a footnote. Tonight, it's the whole story. We are not here to do a magic trick with words. We're going to do 3 things, in order. First, second, show you why your brain insists on calling it left and right, the part that really is in your head. And third, the part almost nobody tells you straight, show you the experiment, with the names, the dates, the temperature, and the journal page numbers on screen, where nature got caught having a favorite hand. We are not competing with the famous mirror video. We're finishing it. Let's kill the left-right idea with your own hand. No math yet, just a finger. Walk to a mirror and touch it. Put your fingertip on the glass. Now look at where your reflection's fingertip is. It's touching the same spot from the other side, pressed right up against yours. Now slide your finger to the left edge of the mirror, toward the wall on your left. Watch the reflection. Its finger goes to the same edge, the left edge of the glass, as you face it. It did not cross over to the right. Slide up. The reflection slides up. Slide down. It slides down. So pause on that. The left side of the room is still on the left in the mirror. The right side is still on the right. Up is up, down is down. If the mirror really swapped left and right, your finger on the left would show up on the right. It doesn't. The light goes straight from your fingertip to the glass and bounces straight back. It doesn't loop around. It doesn't cross the room. There is no little man behind the glass turning your image around. So if left is still left, and right is still right, and up is still up, where on earth did the reversal come from? It came from the only direction left over, the one pointing at the glass. Your fingertip was pointing away from you, toward the mirror. Its reflection points back, toward you. Forward became backward. That's the whole flip, front to back. Let me make it physical. Hold up your right hand, palm toward the mirror, fingers up. Look at the reflection. Now here is the careful part. The reflection's thumb. On your real right hand, with the palm facing away from you toward the glass, your thumb points to the left. Look at the hand in the mirror, a palm facing you, thumb also pointing to your left. The up stayed up. The left-right of the room stayed put. What changed is that the palm, which was facing away from you, is now facing toward you. The hand got turned inside out along the depth axis, and a right hand turned inside out along one axis is a left hand. Here's another way to feel it. Imagine a soft rubber mask of your own face, and you hold it up facing the mirror, nose pointing at the glass. The light from the tip of your nose has a short trip straight to the glass, straight back. The light from your ears, set further back, has a longer trip. The mirror keeps every part of you in its place, left to right and top to bottom, but it reverses the order of depth. The nose, that was nearest the glass, pointing into the room, now points back out of the mirror toward you. Everything that stuck forward now sticks backward. The mirror has taken the front-to-back stack of you and turned it over, like flipping a deck of cards end for end, while keeping the rows in place. Squash that reverse depth you flat against the glass, and you've got your reflection. There's an old demonstration with a glove that makes this unforgettable. Take a right-handed glove. If you could grab the fingertips and pull them back through the wrist, turn the whole thing inside out, you would be holding a left-handed glove. You didn't add anything. You didn't paint it. You reversed it through one direction. The thickness and its handedness flipped. That is exactly, precisely, what a mirror does to you. It turns space inside out along the line of sight. It takes the you that pokes forward into the room and squashes you back out the other way. Now, I want to give you the grown-up version of that because it's beautiful and it'll matter in 20 minutes when we get to the Nobel Prize. Here's a fact you can check, and it's the hinge of the entire video. There are two kinds of ways to move an object around in space without bending it. There are turns, and there are flips. A turn, a rotation, is anything you can do to a solid object by spinning it. Roll it, tilt it, spin it, on any axis, in any combination. Pick up a coffee mug and turn it any way you like. No matter how you spin it, a right-handed mug stays right-handed. You can never, by turning, convert a right hand into a left hand. Try it. Rotate your right hand into every orientation you can manage. It is always, stubbornly, a right hand. A flip, a reflection, is different in kind. A mirror reflection takes a right hand and gives you a left hand, and there is no amount of turning that will get you back. These two operations are not just different by degree. Mathematicians have a clean way to tell them apart, and I'm going to hand it to you because it's the cleanest idea in this whole story. If you write down the rule for any rotation as a little grid of numbers, and you don't need to know how that grid has a number you can compute from it called the determinant. For every possible rotation, no matter how complicated, that number comes out to exactly +1. For every reflection, every mirror flip, it comes out to exactly -1. +1 is a turn, -1 is a flip, and nothing you can do by turning will ever change that sign. Here's a way to feel why turning can't do it, in 2 dimensions where you can picture it perfectly. Draw the letter R on a piece of clear glass and look at it. Now turn the glass any way you like in the flat plane, spin it, and the R rotates but stays a normal R. But flip the glass over to look at the back, and now you see a backwards R, and no amount of in-plane spinning will ever turn that backwards R into a forwards one. To fix it, you'd have to flip it back, reflect it again. One flip leaves you stuck. A second flip undoes it. That's the deep rule. Reflections come in a different family from rotations, and you can only escape a reflection with another reflection. A single mirror leaves you in the other family, the improper one, permanently, until you find a second mirror. Physicists call a turn a proper rotation and a flip an improper rotation. And that word improper is doing a lot of honest work. A mirror image is improper. It is a version of you that cannot be reached from the real you by any motion through space. You can walk around the back of the mirror, do a handstand, cartwheel, whatever you like. You will never make your body match your reflection, because matching it would require flipping a sign that motion cannot flip. So sit with this, because it's the opposite of it's all in your head. The mirror is not showing you yourself from a new angle. It is showing you an object that does not exist in your world, your left-handed twin, who could never be built by turning the real you around. That difference is as real and as permanent as the difference between a left shoe and a right shoe. You will never rotate a left shoe onto a right foot, no matter how you twist. You already know this in your bones, by the way. You've never once tried to put a right shoe on your left foot and expected it to fit by turning it. You know, without being taught the word, that a left shoe and a right shoe are different in a way that no amount of rotating fixes. You'd have to turn one inside out, reflect it to match the other. Same with screws. A normal screw and a left-handed screw will defeat each other forever. No spinning converts one thread into the other. Hands, shoes, screws, gloves, seashells, the twist in a strand of your DNA. The world is full of objects that come in 2 mirror versions that can't be rotated into each other. Chemists and physicists have a single word for that property, chirality, from the Greek for hand. A thing is chiral if it differs from its mirror image. And the entire mystery of the bathroom mirror is really one sentence. A mirror changes your chirality, and your body is chiral enough to notice, but symmetric enough to misread it as left and right. Bookmark that word. Improper. We're coming back to it, and when we do, it'll have a Nobel Prize attached. Okay, so the mirror flips depth, and that flip secretly swaps your handedness. Fair. But then why does every single person on Earth walk away from the mirror saying it reversed left and right? Why not it reversed front and back, which is the truth? This is the part the famous version gets right, and it's worth getting right, because it's a genuinely lovely piece of psychology. The reason is you. Specifically, the reason is the shape of you. Look at your body. Left to right, you are almost a mirror image of yourself. One eye here, one eye there. One ear, one ear. One arm, roughly matching? If I reflected you left to right and didn't tell you, you'd barely notice. But front to back, you are wildly different. Your face is on the front, the back of your head is on the back. And top to bottom, you're different too, head up, feet down. You are a creature that is nearly symmetric across one axis and lopsided across the other two. Now here's what your brain does in the half second you look in the mirror. It sees a human-shaped thing facing you, and it asks, automatically, without permission, how would I have to move to be standing where that person is, facing me? And there's an obvious answer. You imagine walking around behind the glass and turning to face yourself. And when you turn to face someone, how do you turn? You pivot. You spin around your vertical axis, the up-down line, like a door on its hinge. Nobody does a handstand to turn around. You rotate left to right. And that imagined pivot is the whole illusion. When you spin yourself around the vertical axis to match your reflection, your real right hand swings around to the side where the reflection's left hand is. So your brain compares the two, sees the mismatch on the left-right axis because that's the axis you mentally rotated around, and blames the mirror for swapping left and right. But the mirror never rotated anything. You did, in your imagination. The mirror just flipped depth. You added the spin. You can catch your brain doing this with words, which is where it's most obvious. Hold a book up to the mirror, and the text looks reversed, every letter running backwards. But look closely at a single letter, a capital E. In the mirror, its three horizontal bars still point the same way they did in your hand. Top bar on top, bottom bar on bottom. The vertical stroke is still on the same side of the room it was on. Nothing about the letter moved left or right in space. What flipped is the front to back of the page. The printed side that faced you now faces the glass and your reading brain, which scans left to right, reports that as the words are backwards. It's the same illusion, smaller. That's also why the word on the front of an ambulance is painted reversed. So that when it lands in your rearview mirror, which flips depth, it reads forward to you. The sign painter is just undoing, in advance, the one flip the mirror does. Want the proof that it's the spin and not the mirror? Change how you'd turn. Lie down on the floor in front of a mirror, head pointing to one wall. The mirror still only flips depth. But now picture a different creature. Say you couldn't pivot side to side at all, only roll like a log on the ground. A log-shaped you, to face, its reflection, wouldn't pivot around the vertical. It would roll head over heels around a horizontal axis. And then it would look in the glass and swear, absolutely swear, that the mirror reverses up and down. It would complain the ceiling is on the floor. Same mirror, same physics. The reversal it sees depends entirely on which way it imagines turning to match. So that's the resolution of the puzzle that's bugged people for centuries. There is no left-right chemical in the glass. The mirror does one honest, simple thing, flip the through axis. Then your bilaterally symmetric body, and the particular way bodies like yours turn around, dresses that one flip up as a left-right swap. The physics is simple, the geometry is simple, the confusion is biological, and it is, genuinely, partly in your head. If that were the end, it would be a fine video. A nice you fooled yourself twist. But I promised you the half they leave out. And here's where the bathroom sink connects to the deepest known fact about the shape of reality. Because there's a question hiding under all of this. And for 300 years, the smartest people alive were sure they knew the answer. They were wrong. Here's the question. Forget your body. Forget psychology. Ask it about the laws of nature themselves. Does the universe have a preferred hand? Is there any difference at all between our world and its mirror image? Let me make that concrete with a puzzle that physicists genuinely lost sleep over. It's sometimes called the Ozma Problem, after a real attempt to listen for alien signals. The writer Martin Gardner built a whole book around it. The Ambidextrous Universe. Here it is. Imagine you're on the radio with an intelligent being on a planet around another star. You've never seen each other. You want to teach them the word left. Try it. You can't point. You can't send a photo. You can only send words and ideas you're both sure to share. You try. You say, left is the side of my body where my heart is. They say, which side is that? You say, the side where, if I face the rising sun, it's on my end. You stop, because their planet might spin the other way and rise their sun in the other direction. You say, take a screw, turn it clockwise, it goes in, and you stop, because clockwise is just another word for a direction you haven't defined, and anyway they could make their screws the other way. Every single thing you reach for to define left turns out to be a convention, an arbitrary choice that a mirror image civilization would have made the opposite way and never noticed. Take a second with how strange that is, because it's easy to skate past. You can teach the alien big and small, send them a count of hydrogen wavelengths, and they can build a ruler. You can teach them hot and cold, fast and slow, positive and negative charge, matter. All of it travels over the radio, because all of it is tied to something physical you both can measure. But left kept slipping through your fingers, and the reason is profound. If the laws of nature are perfectly even-handed, then left isn't a fact about the universe at all. It's a label, like deciding to drive on one side of the road real for us, but with no echo anywhere in the physics. Two civilizations could agree on every law of nature and still have no way to check whether they meant the same thing by left. That's not a gap in your vocabulary. It's a statement that the universe itself has no opinion. And here's why it felt impossible. For 3 centuries, every law of physics anyone had written down worked exactly the same in a mirror. Watch billiard balls collide, then watch the mirror image of that collision. Both are perfectly legal games of pool. You cannot tell which is the reflection. Drop a ball. The mirror drop ball falls just as Newton says. Electricity, magnetism, gravity, run any of them through a mirror, and the laws don't blink. Physicists gave this a name: parity. Parity symmetry is the statement that the mirror image world obeys the very same laws as ours, and everyone believed it, completely, because everywhere they looked, it held. And if parity were truly absolute, if the universe genuinely could not tell its own reflection from the real thing, then teaching left over the radio would be flat out impossible. Not hard, impossible. There would be no experiment, anywhere, that comes out one way in our world and the mirror flipped way in the reflection. The two would be physically identical. Left would be a word with no universal meaning. For a long time, that's where it sat. Nature looked perfectly ambidextrous. Then, in 1956, 2 physicists asked a question that sounds almost too simple. Has anyone actually checked? Has anyone tested parity in every force, or did we just assume it? The 2 physicists were Tsung-Dao Lee and Chen-Ning Yang. They went digging through the experiments, and they found something startling. Parity had been tested carefully for gravity, for electromagnetism, for the strong nuclear force that holds nuclei together. But there was a 4th force, the weak nuclear force, the one responsible for certain kinds of radioactive decay, and for the weak force. Nobody had ever actually tested whether the mirror world plays by the same rules. Everyone had assumed it, no one had checked, and they weren't asking out of nowhere. There was a genuine mystery nagging at physics that year, and it's worth a minute because it's the thread they pulled. Experimenters had found 2 particles, we call them kaons now, that looked, by every measure anyone could take, like the exact same particle. Same mass, same lifetime, identical twins, but they decayed differently. One of them broke apart into 2 lighter particles called pions. The other broke into 3. And here's the catch. By the bookkeeping of parity, a 2-pion ending and a 3-pion ending have opposite-handedness. They can't both come from one particle, not if parity is sacred. So physicists were stuck with an ugly choice. Either these 2 identical-looking particles were somehow different after all, or parity itself was not as ironclad as everyone believed. They called it the theta-tau puzzle, and it was making people uncomfortable. There's a lovely human moment here, and it belongs on this channel especially. At a physics conference in April 1956, the puzzle came up, and a young physicist named Martin Bloch asked a colleague, what if parity just isn't conserved? That colleague was Richard Feynman, and Feynman, instead of swatting it away, stood up and put the question to the whole room. Could it be that nature has no built-in way to define left from right, and we've simply assumed it does? He didn't have the answer, but he made the room sit with the question. That's the spirit we're working in tonight. Not, here's a shocking fact, just has anyone actually checked? Li and Yang checked. And on the 1st of October 1956, they published a paper with a quiet, devastating title, Question of Parity Conservation in Weak Interactions. It ran in the journal Physical Review, volume 104, pages 254 to 258. In it, they said, in effect, we don't know that the weak force respects the mirror, and here are experiments that could find out. A quick word on that fourth force, because it's the quiet villain of this whole story. You know gravity, and you know magnetism. The weak nuclear force is shyer and stranger. It doesn't hold things together or pull them down. What it mostly does is let particles change identity. It's the force that lets a neutron inside a nucleus turn into a proton, flinging out an electron as it does. That process is called beta decay, and it is the weak force's signature. The sun runs on a cousin of it. Carbon dating depends on it. And because it's the one force that changes what particles are, it turned out to be the one place nature kept its handedness hidden. The other three forces are perfect mirror citizens. The weak force is the outlaw. One of those experiments was taken up by a physicist named Chien-Shiung Wu at the National Bureau of Standards in Washington. She was one of the great experimentalists of the century, and the thing she built was a marvel of patience. Here's what she did, and I want you to feel how hard it was. She took atoms of cobalt, 6-0, a radioactive form of cobalt that decays by the weak force, spitting out an electron each time. Normally, those atoms point every which way, like a bucket of compass needles all jumbled. To ask the mirror question, she needed them all lined up, pointing the same way, like a marching band turned to face one direction. And atoms only line up and stay lined up if you make them cold enough that the heat jiggling stops fighting you. So she cooled the cobalt to about 1/100th of a degree above absolute zero. Let me put that in human terms. Absolute zero is the coldest temperature there is, about minus 273 degrees Celsius, minus 460 Fahrenheit. She got to within 1/100th of 1 degree of it, 0.01 Kelvin, colder than anywhere in deep space, using a trick called adiabatic demagnetization, where you align a paramagnetic salt with a magnetic field and then release it, and the releasing itself pulls heat out and chills the crystal. With the atoms that cold and a magnetic field holding them, the cobalt nuclei finally lined up, all spinning the same way, and the polarization didn't last. As the crystal slowly warmed, the lineup decayed over about 1/4 of an hour, so she had roughly 15 minutes, each run, to count. Then the simple, decisive question. The nuclei are all spinning the same way. They fire out electrons as they decay. Do the electrons come out evenly, as many heading one way along the spin as the other, or do they prefer a direction? And I want you to understand how little the experts expected this. The smartest people alive were betting against it. Wolfgang Pauli, one of the towering minds of physics, wrote to a colleague in January 1957 that he refused to believe it, in a line that's now famous. I do not believe that the Lord is a weak left-hander, and he said he was ready to bet a very large sum that the experiment would come out symmetric. Richard Feynman offered 50-1 odds against. Another physicist, Felix Bloch, said he'd bet his hat. These were not fools. They were the best in the world, and they were certain the mirror would hold, because it always had. That's what makes the next sentence one of the great moments in science. If parity holds, if the universe can't tell left from right, the electrons must come out evenly, equal numbers each way, because the mirror image of more electrons going up is more electrons going down, and if both worlds obey the same law, nature has no reason to prefer one. They did not come out evenly. The electrons came out preferentially in one direction, pointed the opposite way from the nuclear spin. More went one way than the other. Nature had a preference. And that one lopsided count, 15 minutes at 1/100th of a degree above absolute zero, broke a 300-year-old law. Wu and her collaborators, Ambler, Hayward, Hopps, and Hudson, published it. Experimental Test of Parity Conservation in Beta Decay, Physical Review, Volume 105, pages 1413 to 1415, on February 15th, 1957. Months after Li and Yang asked the question, the answer was in print. For the weak force, the mirror world does not obey the same laws. Parity is violated. Let that land. Take a movie of Wu's experiment. Now play its mirror image. In the mirror, the atoms appear to spin the other way, but the electrons still come out the same actual direction, and that combination never happens in our universe. The mirror image experiment is not a legal experiment. It is a movie of something that cannot occur. For the first time in history, someone had found a physical event whose reflection is impossible, and she wasn't the only one who caught it. The moment word got out that Wu was seeing a large effect, a second team at Columbia, Richard Garwin, Leon Lederman, and Marcel Weinrich ran a completely different version of the test over a single weekend in January 1957. Instead of cobalt nuclei, they watched the decay of particles called muons, and they saw the same lopsidedness, nature preferring one hand. Lederman later said he and Garwin waited a very painful week until Wu was ready, so the two results could appear together. They did back-to-back in the very same issue of Physical Review. Wu's on pages 1413 to 1415, the muon paper on 1415 to 1417. Two independent experiments, two different particles, one verdict. When two teams using totally different methods catch the same thing in the same week, that's not a fluke, that's a law cracking. How fast did the world take it seriously? Li and Yang were awarded the Nobel Prize in Physics in 1957. The same year. That essentially never happens. The Nobel Committee is famously slow. The speed tells you how big this was. A law everyone trusted had a crack in it, and the crack was real. And I want to be honest about something the tidy version skips. Wu, whose hands actually did the experiment, was not included in that Nobel. Li and Yang proposed it. Wu proved it. The prize went to the two theorists. Physicists have argued about that omission ever since, and I think it's worth saying her name clearly. Qian Wu. The experiment is hers, so the weak force has a preference. But you might be thinking, a slight lopsidedness in how some electrons fly out of cold cobalt, is that really a big deal? Or just a tiny statistical lean? Here's how big a deal it is. Li and Yang, having broken parity, made a bolder guess that one particle in nature might be so committed to a single-handedness that it never, ever comes the other way. That particle is the neutrino, a ghostly speck thrown off in weak decays, so shy it can pass through a light year of lead without touching anything. And the claim was staggering. Every neutrino the weak force makes spins, in a sense, left-handed. Its antimatter partner, the antineutrino, always right-handed, not mostly, not on average. Always. In 1958, a physicist named Maurice Goldhaber and his colleagues figured out an ingenious way to actually measure the handedness of the neutrino, and it came back left-handed exactly as predicted. Sit with that. The universe doesn't just lean left in the weak force. For the neutrino, it is left, with no right-handed version showing up at all. That is the deepest sense in which reality has a hand. Your bathroom mirror, flipping its one harmless axis, is the toy model of an asymmetry that runs right down into the most fundamental particles we know. The mirror image of a left-handed neutrino, a right-handed one, is something the weak force simply does not produce. The reflection isn't just unusual. It's missing from the world. Now come back to the bathroom. Stand at the sink again. Remember the Ozma Problem teaching left to an alien you can't point for? After Wu, it has an answer. You can finally do it. You say, friend, take cobalt, 6-0. Cool it to 1/100 of a degree above absolute zero. Line up the nuclei with a magnetic field. Watch which way the electrons prefer to fly. Call the direction they avoid up, and the spin that defines it gives you a true universal sense of rotation, and from that, left. And they could build it on their planet, having never seen a human, and get left exactly right. The universe itself, through the weak force, has a built-in handedness it's willing to share. Left finally means something everywhere. There's one catch, and it's gorgeous. If your alien friend happens to be made of antimatter, the instructions come out backwards. Their anti-cobalt fires electrons the other way, and they'd build the mirror image of what you meant. So the one situation where left still slips is between matter and antimatter. Which means if you ever do meet that alien, and they're made of antimatter, and they offer to shake hands, don't. The two of you touching would annihilate in a flash of pure energy. A handshake as the end of the world. That's not a joke I made up. It's the actual physics of matter meeting antimatter, and the handedness of the weak force is how you'd ever have known which kind they are. So here is the reframe. Your reflection is not you from another angle. It is your enantiomorph, your perfect left-handed twin, an improper copy, determinant -1, that no rotation in the universe can turn back into you. For almost everything that twin does, the laws of physics would treat it exactly like you. Gravity would hold it down, light would bounce off it. Its mirror chemistry would, to a first look, run like yours. To a first look. Because here the competitor's version reaches for a dramatic line that you'd step into the mirror world and starve, unable to eat the food there, and it's almost right. But it's sloppy, and you deserve the precise version. Life on Earth is handed, all the way down. The amino acids that build your proteins are, with a single exception, all left-handed. 19 of the 20 that your genes code for are the left-handed form. The 20th, glycine, is the one amino acid with no handedness at all. And the sugars in your DNA and RNA, ribose and deoxyribose, are all right-handed. Every living thing, from the bacteria on this sink to the blue whale, uses the same hands. We call it homochirality, and it is one of the deepest unsolved riddles in biology. We do not know why life picked these hands and not the others. So your mirror twin, built from right-handed amino acids and left-handed sugars, really would be biochemically a stranger here, its molecules the wrong shape for your enzymes to grip. But notice the honest version is better than the dramatic one. It's not that you'd starve on right-handed food as a throwaway. It's that handedness is stamped into the molecules of life itself, for a reason nobody has cracked, and your reflection quietly shows you the road not taken. And once you start seeing handedness, you can't stop. The shell of a garden snail almost always coils one way. Climbing vines tend to twist with a preferred sense. The double helix of your DNA spirals right-handed, every cell, every species. The proteins it builds fold into right-handed corkscrews called alpha helices. Your heart sits a little to the left. Your gut coils in a consistent direction. You are, at every scale, from the molecule up, a handed object living in a world that in its everyday forces couldn't care less which hand you are. Sitting on top of a single force, deep down, that secretly does. The mirror is where those two facts meet. The harmless reflection on the surface, the broken symmetry underneath. Let me give you things you can actually use. First, the one sentence that dissolves the mirror puzzle forever, so you never get tangled in it again. A mirror reverses front and back, not left and right. You call it left and right because, to match your reflection, your mind pivots you around the vertical axis. That's it. That's the whole resolution in one breath. Say it to someone tonight and watch them argue, then watch them get it. Second, a test you can run at the sink. Bring up, text your phone, a book, and hold it to the mirror. The letters look flipped left to right, right? Now physically rotate the page by flipping it top over bottom instead of side over side to face the glass. The mirror text now reads top to bottom flipped instead. The direction of reversal followed how you turned the page, not the mirror. You just did Wu's logic with a paperback. The asymmetry lives in the turning, not the glass. Third, a way to win an argument you'll definitely have. Someone will insist the mirror obviously flips left and right and point at their reflection's hand as proof. Don't argue about hands. Ask them one question. Which way did the up and down go? It stayed put. Then ask, if the glass had a rule that flips left-right but spares up-down, where in the flat, featureless sheet of glass is that rule written? There's no mechanism for it, because there's no such rule. The glass treats every direction across its face identically. The only direction it singles out is the one perpendicular to it, the way the light comes and goes. Corner them on the missing mechanism and the illusion dissolves in real time. Fourth, the thing to remember when someone tells you it's all just in your head, half of it is the left-right label is yours. But the other half is the realest thing physics has ever found about the shape of space. Underneath the harmless bathroom illusion sits a genuine, measured, Nobel-winning asymmetry of the universe. The next time you face a mirror, you are looking at the one operation, the improper one, the flip with the minus sign that nature itself was caught unable to perform symmetrically. You meet it every morning, half asleep, with a toothbrush. That's the beauty of it. The most ordinary object in your house, a sheet of glass with some metal on the back, turns out to be a door to the deepest question we know how to ask. Does the universe have a hand? For 300 years we were sure it didn't. Then someone got cold enough, patient enough, and careful enough to actually look? And the answer came back, yes, it does. And you've been holding that question, unknowingly, every single day, right there at the sink. Here's my question for you, and there's no wrong answer. When you first heard mirrors reverse left and right, did you ever, even as a kid, feel that something was off about it? That it didn't quite add up? Tell me in the comments what was the first thing that made you doubt it. I read those. If a 30-minute walk from your bathroom sink to a 1,957 Nobel Prize is the kind of trip you want to keep taking with the names and the page numbers on screen, and an honest line between what we've proven and what we still can't explain, then subscribe to the Physics Storyteller. We don't do mind-blowing, we do, here's the source. And next time, we're going to pull on the thread we left dangling tonight, the antimatter handshake. Why a mirror-flipped universe and an antimatter universe aren't quite the same thing, and what happened when physicists tried to fix parity by adding antimatter and got caught a second time. That's the next chapter, here on the Physics Storyteller. Until then, tomorrow morning, look at that person in the glass. Don't just see a reflection. See the depth collapsing. See the one axis flipping. And remember, that's not you. That's the twin the universe can't quite build. Tell someone that tonight. Watch their face.